Hello, everybody. Okay, today we are talking about this problem with Planet X. All right, and believe it or not, this is going to be one of the bigger multi-step problems they're going to do this year. There's actually going to be 3 steps. Yeah, so it talks about how you're going to have acceleration on a new planet. All right, and right over here, it's going to talk about that on Planet X, you have an acceleration that's 1/5. All right, so we'll deal with that in a little bit. But first, we want to talk about how it says it takes 4.2 seconds for something to fall on Earth. Okay, so let's tackle that part of the problem first. All right, so we have that we know that our time is equal to 4.2 seconds. All right, we don't think we know more than that, but we do, because what else do we know? Well, we know, I'm going to leave my seconds there. All right, that's a really ugly S, but I'll work. We know that the acceleration is going to be negative 9.8. Okay. We also see that the word rest is right there, right? And if we remember from the beginning of the year, rest means the initial velocity is 0. Same with if I saw the word drop. Okay, we know that the initial velocity is going to be 0. All right, there's meters per second squared up there. So what we're going to do first, our first step in this problem, all right, step number 1, I'm just going to do a 1 with a circle around it, is we need to figure out how far this object's going to fall on Earth. So we are going to do xf equals question mark. Okay, so looking at our list of givens, we know we can go through our 2 questions. 1, do I see time on my list of givens? Yes, I do. So the VS squared equation is not going to work. 2, do I see an xf or d? And this is really xf slash d equals question mark. And yeah, I see that too. So it means the big ugly is what we're going to have to use. So we do our big ugly. xf is equal to xi plus vi times t plus 1/2 at squared. All right. Now, we know that the initial position or the initial velocity was 0 and anything times 0, 0, so that's gone, 0. All right. We also know that if I don't mention or ask for initial position, we're going to say that's 0 as well, so that's gone, 0. So the only thing we have left is just 1/2 at squared. All right. So we plug it in. We have our 1/2. We have a, which is always negative 9.8. Then we have our t squared. T is 4.2 in this problem for me. Squared. All right. We plug that in, and we negative 86.436 meters. All right, so we'll keep that distance as a negative. We know that normally, I'm just going to tell you in the U-text if it's going to ask for a negative or a positive answer. So we'll leave it as a negative for right now. Okay, so now moving on. Now we're going to go to step 2. Step 2, we now have to figure out what the acceleration is on our new planet. So the acceleration is going to be what we look for, okay? And we know that it says that acceleration is 1/5 that on Earth. So all we're going to do is say, all right, well, that's going to be 1/5, so 9.8 divided by 5. All right, and that acceleration is 1.96 meters per second squared. Okay? All right, now we're going to put those 2 things that we figured out together and talk about the new planet. So now I'm going to go to my new planet. I'm going to say, all right, step number 3. Step number 3, we need to know what the time is, right? We're looking for seconds. So we know t equals question mark. What else do we know? We know a on this new planet is 1.96. Now, I will say this, we should have made this a negative and that a negative, really just to make sure that our negatives cancel out. All right, acceleration is down. This is always pulling down, and I did over here is down also as a negative. So we should have this as a negative 1.96 as well. All right. We also know the distance it's going to travel on the new planet is the same as the distance traveled on the old planet. So we're going to say xf/d is equal to, so xf/d is negative 86.436. Now, I am not rounding at all right now. The reason I'm not rounding is that if I round a little bit, especially a little too much in between steps, when I get my final answer, it could be outside of 1% error. So never round in between steps. All right. Okay, what else do we know about this planet? Well, we know that it's going to be dropped also. So we still have an initial velocity of 0. All right. And now I can ask myself the two questions. One, do I see time on my list of givens? Yes, I do. All right. Two, do I see xf/d in my list of givens? Yes, I do. So it's going to be the big ugly once again. I have xf is equal to xi plus vi times t plus 1/2 at squared. All right. Once again, initial position is gone. Initial velocity is gone. And we only have 1/2 at squared. So we have xf is equal to 1/2 at squared. Now this time we need to look for time. And I challenge you, don't put numbers in first. Try doing the letters and move the letters around before you stick in numbers. So how are we going to do our algebra to get that? First, I got to get rid of the 2 on both spots. All right, so multiply on both sides by 2, and that cancels out the 1/2. Okay. Now I'm going to divide both sides by a. I have to work outside in, all right? So t has to be the very last thing I touch. So I'm going to divide it on both sides, and the a is gone. So now I have 2xf divided by a is equal to my t squared. Last step should be the square root. A really ugly square root, but it'll work. Okay, and I know that now I have t is equal to square root of 2xf over a. Or square root 2 times my 86, and put in the whole number, everything you got, divided by my acceleration, and that's negative, and my acceleration is negative also, 1.96. So we're not going to be square rooting any negative numbers. That's good. All right, plug it out, and you'll get your answer.